So for work example 2.21 on page 68 of your textbook has to do with what a scale reads when someone is standing on a bathroom scale in an elevator. So here's our elevator, and one of the things that's helpful to remember in these problems is that a scale, what it's reading is the reaction force, this force R, that if the elevator is standing still, that will be equal and opposite to mg, right? So if the elevator is standing still, the reaction force, which is what the scale will read, is equal to the person's weight. No problem. This is also true if the elevator is moving, as long as it's moving with a constant velocity. However, when the elevator is accelerating, that's when things change. And what's really critical here is the direction that it's accelerating. So if the elevator is accelerating upward, then R has to be larger than mg in order for there to be a net upward force and therefore an upward acceleration. So what the scale would read in this case, or R, if there's an upward acceleration, it's going to be mg plus the force needed to make the person accelerate, and that can be rearranged to m times g plus the upward acceleration. Now, on the other hand, if the elevator is accelerating in the downward direction, all that means is that now the net force has to be greater in the downward direction, so R will be less than the weight. So the only thing that changes if the acceleration is downward is that the scale reads mg minus a. So that's the big difference. That should help you with 20.21. It might even help you with 20.22.